split rings through it. The big circles.
Yeah.
They have one either side. They're like claws.
I have no idea what the shape is.
So you have a piece of timber like this, and another piece of timber like that, and you have these circles. Imagine that being a circle, and here's like a claw, and it goes into the timber, and through the middle is a hole drilled, and a nut and a bolt, and they tighten it up a bit like a machine that's what are those medieval machines that's making a person stretch or whatever. They're tightening it up, and then that means that the timber can't move that way, the shear force. So a lot of trusses have got these split rings on them because you don't want it moving like that, and you don't want it moving like that, and you don't want it moving sideways too. So what that does, the claw, the picture is in my timber where you'll see it in the timber notes, pulls it all together, and there's quite a few of those on this truss. Yeah. Okay, I think instead of doing the timber notes first, I'll have a go at the 3D, because if you can get your 3D drawn up, it will help you a lot, because you all know you can spin a 3D around and have a look at the different views, and that's going to help a lot of you figure out what things look like sideways and all the rest. And also it's a little bit of a lead-in into your Revit. Revit is a program that I call 4D, not 3D, because it gives out quantities. Unfortunately, it still doesn't give out very good reinforcing schedules, but it does do all the other stuff that's on there, steel, timber, and all that. So if you do your Revit model properly, it will give you the quantities and the lengths and all the rest that you've used. So from a quantity surveyor's point of view, that's the people that work out the cost of the job, it's really good because they pretty much can put that into a spreadsheet and come up with costs. And if you move a beam or change the size, the cost will change as well, you know, and the quantity. So Revit's something quite cool to look forward to in the future for your last year at Unitec. And you know, do ask other students that are doing it, because some of them find it, they don't like it, some of them are really enjoying it. But what I do here is AutoCAD 3D, and it's important that you've already had your first 3D class with Ingrid. She showed you how to rotate a block, I think, by memory, and kind of zoom in on it a bit. Yeah, pretty easy stuff, but in some ways we're going to use some of those commands today as well. So I would prefer what you do is, hopefully we'll get a nice clear video of this for you to revise, but it's always a good idea to write down things that I say as well, so you can relate to the video. For example, I will show you the tools that I use to do 3D, where to get them, how to get them immediately. Now, if you write that down, then when it comes to the video, you've already got that ready to go, you know. And also a few more tips and tricks as well. Now, you can't avoid having to draw this up in 2D, because we're going to take it from 2D to 3D. Okay. So, as you can see, I've already pre-mixed all this and put it in the oven. And in order to do a 3D drawing, I've done P-lines for everything. So, for example, I've turned that into a P-line. I've turned that into a P-line there. I've turned that into a P-line. So when you do your elevation drawing, I wouldn't suggest you do that for your elevation drawing, because you're going to have to break I'll give you an example. When you draw that up in elevation, this line here will be dashed because it's in behind, and that line there might be dashed down here because it's in behind, right? So in your elevation drawing, if you do that as a P line, you can't just make part of it dashed and part of it not dashed. So you're going to have to draw it as individual lines on your elevation. So copy that over to the side for your 3D drawing, and then start turning them into P lines. So I've already done that with quite a few of these things here. And I'm sure all of you are capable of doing that pretty reasonably quickly. Now the problem, we've got a few problems with this one. I've already drawn the concrete slab on here, and I've drawn this particular view of the slab first up to make it a little bit easier for myself. How long is that by memory? I'll just list this.
400.
No, the length of the slab is
6.8.
6.8. Yeah. Okay. That's good.
8 meters.
Right. Well, if we go into our 3D views, we go view 3D views. Is it there somewhere? Yeah, 3D views. And the one I like to use, and the one I teach students all the time, is this thing called Southwest Isometric. So, oops, I missed it again. View, 3D views, and Southwest Isometric. And you'll see that everything turns into a bit of a 3D. Now the problem is that we've drawn it all flat, right? But I'm going to put everything in 3D on the flat for this drawing, because I feel it's the easiest and quickest way to do it. So the first thing I'm going to do is this here, and I'm going to right click on it. Now I can right click there, I can right click up here. I'm getting the same command, see it popping up? And if I go to AutoCAD, it gives me all the icons that are turned on at the moment. So that is actually a quick way of bringing an icon back if you lose it. You know, the icons on the side. Only problem is you need to know what they're called. I think the layer one's pretty obvious, but the draw one is too. But some of the others aren't so obvious. But anyway, when you have it in AutoCAD Classic, that's what it looks like. We need the modeling ones. So we're going to turn on the modeling ones. And look at this, I've got a whole bunch of modeling tools here. Now if you pick those dots there, you can move them wherever you like. Now for some of you, you've got 2 screens. Some of you have only got one. If you're working from home, you might have your laptop and your screen, so you can move these onto your laptop so you can click on them and still have maximum real estate on the right hand screen. So what have we got here? We've got what looks to be already some shapes here we can use, and I would suggest this cylinder one would be one you might be able to use to make a bolt up. There's a hexagonal one, no, there's a donut, so you may have to draw a P-line hexagonal as well. But the one we're going to be using today is the extrude one. So if you hold your mouse on it, you'll see the extrude one. We may end up using the combine one, which is where you combine 2 things to form a union. So if you hold your mouse down, it pretty much tells you how to do it. So it says here to combine 2 things, you select the same objects and then you go enter. So it's pretty much tells you how to do each one. There's one called extract. Now that's quite a good one, because you could just, it depends how many marks you're looking for off me to get from 3 to 5. Your bolts have all got holes. You can put a cylinder into the concrete and go extract, and that'll make it a hole in the concrete. Which, okay, that's probably worth half a mark if you put all the holes in there. The holes for the dyno bolts that hold the brackets. If you want to go the whole 9 yards, you put a bolt in there, okay? And the bolt really only needs to show, all you're going to see of the bolt is the hexagonal top on when I start extruding things, you'll start to see this come to life and you'll know exactly what I'm talking about. Now the other thing is visual styles. Okay, so with the visual styles, we have a 2D wireframe, which is exactly what it says, 2D wireframe. So it'll just show lines. Tip of the century, if your warehouse computer is starting to crash, go back to just 2D wireframe and it'll be fine. Because it doesn't, if it's working fine at the moment, it'll be fine on 2D wireframe, right? Realistic and conceptual, there's not a lot of difference, but they're slightly different. We'll probably go for, I'm not sure, I'll just have another quick look, but probably realistic. These other ones are just different shades of grey. Sketch is quite a hard case one. I know someone that used that. Yeah, they turned the whole drawing into like a sketch, took it to the client says yes, give you the go ahead, we like that. Went back and turned it into realistic and came back and charged them the earth for the drawings with one click of the button. So, you know, they...
They're a bit wise to that now.
Oh, are they? Okay. Yeah. Anyway, it did look like a hand sketch. It was pretty cool. I can show you that at the end of this, if you like. We can turn it.
Yeah, I think the architect's rendering has kind of taken that away from us.
Yeah, I know. All right, so we don't really want to be on wireframe because it gets kind of confusing later on. Let's go for conceptual, see what happens. If it's no good, we'll go to realistic. I would like you to do consensual or realistic when you hand it in, please. I'll go for, did I say conceptual? Go for realistic. Realistic, yeah. Okay, so I'm going to grab this P line here, okay, and I'm going to go to extrude. Look what's happening. All sorts is happening.
But even your rebar is flat.
Yep. Now, what I'm going to do is I'll try to extrude it upways, but it may go the other. And I'm going to type in, oh, I forgot, 6.8 is it? 6,800.
6,800.
6,800. Make sure ortho's on, you don't want it on an angle. And 6,800, enter. Bang. Funny how it went red because my layer that I'm on is red. I want to put that back to white to some sort of yellow layer because it's easier seen by you guys. It won't be timber. Concrete, there we are. Okay. Alright, so I've done my first 3D thing. It kind of looks weird, but it's okay. It's okay. Now, we'll move that over here. And there are different ways to rotate it. If we just rotate it as it is and type the command rotate, we can click on this, enter, and you'll notice that we're kind of just rotating it on its axis like that. So we're not kind of turning it upside down and sideways. So we're not actually flipping it in 3D, are we? However, if we go back down here and we roll along to this thing here, it's what we call a 3D rotate. This is the bit where I could cock it up. I'm going to click on that, I'm going to click on there, enter, and we've got these circles of rotation. I'm going to click on the red one and see what happens. It's turning orange, and I'm going to aim down. Aim down, aim up, aim up. Sorry, the mouse is playing up a bit. I'm aiming up and click.
Because you got ortho and it snaps to 90s.
Put the snaps on.
No, you got ortho. Ortho snaps to 90-degree intervals.
Oh yeah, that's what it's doing. But anyway, I've rotated it. It now looks like the slab in 3D. So I'll just rewind that in case that the recording doesn't quite pick it up clearly. I've ended up with something that's a bit, right, it's not where we want it in 3D. So we go here to 3D rotate, that one there. We click on it, enter. We get these circles. If we click on the red one, it turns orange. And then we aim straight up and go enter. Oh, I didn't. Told you I could cook it up. I'll do it again. Click on there, enter, click on the red one. Now I'll be doing this quite a, that's it, click, done.
Did you change the scale of it just then?
No, it didn't, it's still the same.
And then.
Okay,
can
so,
you- sorry, Roger.
yep.
One more thing, how do you go from a flat bar to a round bar? Now, the reinforcing is 16 mil flat bar.
That's what they look like currently.
In 3D view, because when you put a polyline with a 12 mil thickness, it just puts it at a flat thickness.
Like a
Now to
slab.
get a good impression of it on the 3D
Oh,
view.
you don't have to draw the reinforcing in 3D, you're okay. Yep, you get out of that. Yep, so that's probably, you can sleep at night now. Yeah, I'm sorry if you've been spending your holidays having nightmares about drawing the 3D reinforcing bars, but you didn't have to see me for 2 weeks, so, you know, swings and roundabouts.
I don't think they're sorry about that.
Yeah. Well, Max can't keep away, keeps emailing me. Never mind. Okay, so here's a little bit of a point of contentiousness. I've just drawn my plate at I think 400 by 400, but I said to you that you choose the size of your plate, and you'll have to do a wee bit of that plate design to make sure the bolts fit around the column, right? So for demonstration purposes, please don't necessarily copy mine. It might be okay, it may not be, but you all have to do your own sort of size plates. Once again, you could do the hey bro thing, but you're better off choosing an oddball size so you don't get accused of copying anybody else, i.e. $3.99. Alright, so here's my plate, it's also a P-line. I'm going to click on it, and then I'm going to go to the extrude button, and obviously is the plate 10 mil?
Yep.
Thank you. 10, enter. There's my plate, done and dusted. All right. Now, the column is conveniently already in 3D. I brought it into the drawing. I copied these from you're given these in a separate drawing on Moodle, and so I've already copied them into this drawing. Copy paste. Now these are P lines, and they should extrude. I'll just check that. Yep, they are going to extrude. So if the ones that you bring in aren't P lines, make them into P lines.
And would that just be selecting them all and joining them?
Yes, if they're
Or
single
how?
lines. If they're a block, you may have to explode it first and then join them.
How to explode the bar?
How to explode? Okay. Please, okay. Do not do this on an aeroplane. All right. See that button there on the right hand side?
Okay.
It's explode. Like I said, don't do that on an aeroplane.
You will be a Swiss Army knife.
Yeah, there's a few things you don't pull out of an aeroplane. That's one of them.
I think I lost a couple of them.
I can just see me getting into trouble and being a flight risk now for saying that. Okay, so let's get the H and let's put it. Let's copy this down by my. There it is there. Now, where does that fit? I think it's 50 mil this way. Bear with me, this will suddenly become a lot quicker than you think. So I'm going to do a line along there 50, and then I'm gonna, remember we've got ortho on, just like Lance said, and I'll go 50 that way. And it's very hard to see, but there is a line that finishes right there. Now that's quite an important line because that's where the edge of my column fits. Pretty sure the column is that way round. So I'm going to move that from the corner, so have your snaps on, and I'm going to put it right on the end point there. There we are. It's sitting on the plate. So the next thing is to go into my drawing and just work out the height of that column. I'll just take the height that I've drawn it at. Let's hope I'm right. Please don't copy this at home. And I get 2,530. Does that sound about right? Was it 2,5?
That's not a very big tractor then. That's a little conversion.
2,570, is that, and you've taken the plates into account? So
2 plates.
it's 2,570 minus the plates or plus the plates? So 2,570 minus 10 minus 10?
No, so after minusing the tens,
Yeah.
it's 570.
Okay.
You put the plates, it's 120.
Alright, well, I'm gonna take that as being true, but for the benefit of the tape, blame him if he's wrong, if you're wrong. No, if for the benefit of the tape, you need to just do that calculation yourself, just to check that, right? So 2,570 we're going to use today. So, I'm gonna go over back here to my column, which I'm putting together slowly. I'm gonna grab that, just click on it, go to the extrude, aim up, and I'm going to go 2,570, enter. Now I will change that to a, this is a terrible mouse, I'm going to grab that and I'm going to change that, not to a plate but to something else. Member, L plate, member 3, that'll do, it's green. And obviously you can see that that's in another hemisphere to this, so let's start moving things into the right place. So I'm going to go move, enter from that corner over to that corner. Just getting things dead right. Now if you don't put your snaps on, you're going to end up in the end with really, interesting issues going on, yes?
That's meant to be rotated 90 degrees, no?
I was asking that before, is it?
Yeah, it's
It's
what we've
kind
done
of
on the-
like-
Okay, well that can be done without a 3D rotate, so we can move previous and move it out here. Oops,
The plates as well.
sorry, I thought that was the right way around, but if it's not, we can rotate it over here pretty easily. Now, because that's 400 by 400, it's gonna rotate, I just have to rotate it, the whole thing. So, rotate, grab, enter, and there we are.
Yeah, that's what it is on
That's
the.
what it is?
Yeah.
Okay, so let's move that from that point to that point there. Right, and now, using your 2,570, my friend at the back there, we're going to move the plate at the top, we're going to copy that up to 580. Yes. So go copy, grab the plate, enter from here, aim upwards to 580. Drum roll. Perfect. Now, I'm going to simply copy these around all 4 corners, but if you're going for a few more marks in terms of more than the 60%, then you would probably put your bolts where you work them out to, and here. So on the flat, you would draw a hexagon, and then extrude it a little bit, and maybe a Dynabolt would have a bit of a washer on it, wouldn't it? and then move it onto the plate. And then when we copy all that at once, right? Rather than going, and doing all the plates, you do all your copying early on, so you spend a lot of time getting it all right, and then copy, which is what I'm about to do. Yeah, so I'm just gonna use my window to copy. So I'm gonna go copy and use you've gotta be careful in 3D what you're doing, because you could pick up something in behind on your main drawing and start copying all your rebars all over the place. So, just a warning, when you do a window copy like that, you don't know what's over here, and especially when you start turning it around, you end up with your main drawing in the background, and you start moving, and then you go back to your main drawing and go, someone's ruined my main drawing. So yeah, the other thing is try and do lots of saves, because you don't know, it's like a time bomb, this one, with the trust, believe me. At some point you're gonna probably have a crash. I've got a number you can ring, it's called 0800, I've just crashed and no one gives a damn, okay? So let's copy that from, I can just see Lance, he's already written my sequel. Over there. Now, if you're in one of those moods where you think you want to be really cool, you can hold your shift key down and your middle roller and rotate it. And you can even do a mirror if you want to. So I'm going to go MIRROR. Notice I type my command sometimes. I grab all that, enter from the midpoint of here, and that didn't want to do that, did it? Mirror, I'll try it again. From the midpoint of here, come back that way, enter. Okay, so the columns are up. Now, the next thing is, I think we have to put a beam, don't we? So, does anyone know how long the beam is? I think it's 6 point, it's the width of this.
You got 7.2 and you got 6.8 and you got 8 meters by 6.8. The overall. The 7.2.
Did we do the 6.8 the wrong way?
So no, 6,800 minus 50 from.
Yeah, but did we do, I see it goes the beam, which way, we went 6,800 that way.
Yeah, that's correct.
Correct.
Yeah, that's correct.
So it's 6,800 the
Yeah,
beam?
yeah. Or 6,700 if you minus the ends, the offset ends. for
Base
the-
plates.
Yeah, from the base plates. So just directly on top of the columns, it'll be 6,700 end to end.
Okay, so you wanna bring them 50 mil in from each end,
Yeah, that's what you've done.
have I? On my 3D sketch?
On your three,
Or on my drawing?
So, no, you got it the right way. You cantilever it out over the one side.
or maybe your beams go across the whole plate, can you tell?
Okay, let's make it the length, let's make it 6,800.
Okay.
Okay. And for the benefit of the tape, you do need to check that dimension. I'm gonna click on that. Where's the beam? Where's the, it's this one, isn't it?
Yeah,
that's
that
the-
one.
The skinny one, that's how I remember, I look in the mirror. Okay, so I'm gonna go to, extrude, and I'm gonna go 6,800, and go enter. Okay, so that's a pretty tall beam. Now we've got to use that 3D rotate thing to get it over there. Let's move it a bit closer. And we may actually have to do a rotate like we did before. We'll just see what happens. Okay, so let's do a 3D
Actually,
rotate.
align it.
Beg your pardon?
You choose the align command.
Oh, yeah.
I have never done that in 3D. That's pretty cool.
You can
I'll
align
tell you
it on
what,
2
you wanna-
points.
Do you want to try?
No, if you want to.
Okay, well, what about half a mark for you if it works and half a mark off if it doesn't?
Like
Take a
it.
risk, bro.
Go for it. Take a
Go
risk.
for it.
Well,
I'll gamble half a mark on that one.
For the mark you don't have.
okay,
Someone taking it off.
I don't think this is gonna work.
Good idea.
ALIGN, enter. Click on that.
You gotta choose the right corners though.
Oh, you're not blaming me on this. I'm gonna go from there, that point to, initially, to that point,
No, I think yes.
and that point. I bet you it's not on Google. This is really radical.
Roger, I think you did the other side of the beam there.
I don't think it's gonna move anyway. I think it's a dead
Let's see.
no, and no. Oh my God, it did work.
It's pretty close.
I'm pretty
Have you
upset
scaled
about
it?
having
If you
to
said
give you.
scale yes, it would have put it on.
That has really annoyed me having to honour you for that. But yes, it will work. Yeah. So you can, as long as you don't do the scale thing. I went no for scale.
Yeah, if you did scale, it would have brought the scale onto it.
Your beam's going inside the plate. inside
Yeah,
the-
that was me. I didn't quite put it to the right thing. I didn't think it would move, to be honest. So
Really?
I've been overwhelmed today. So I think we need to mark the midpoint here and move the midpoint of the bottom of that beam to it, and then we'll be right. So sometimes you have to sort of pre-mark where it needs to go, and other times you can just move it into place. So I'm just making a line there, and then I'm just gonna move that. So for the benefit of the tape, where this is gonna be hard, Lance was, I can't say it. I'll build up to it.
Yeah, half mark.
Yeah, yes, yeah,
I get a half mark.
yeah. Unless we find out all holidays he's been practicing that. Yep, so there we are, we've got that beam there, so
I need to email you for that as well.
It's not on the.
it's
middle.
not properly aligned, is it?
No, it's not.
No,
You chose opposite corners of the beam when you were doing it?
yeah, I
Instead of
think we'll go
choosing the same-
backwards a bit to where we were and do it my way, but
User error doesn't negate the fact it's a good idea.
no, the idea is, yeah, I know, yeah. You were, yeah, you were.
What you trying to say?
I can't say the word right, but some of them. Okay, I've done the, rotate thing, and now I'm just gonna move that on the midpoint. This is the slow way I was gonna do it. We nearly got it right with Lance, and I think I probably got the wrong corners, the wrong points, so I'll blame myself. There we are, and I'll copy that. We haven't even got to the interesting bit yet, the bit that I've never done before. You know, so the cool thing about 3D is you're building up a model and it's coming into play, right in front of your eyes, and you know, that's why it's easy for students to get a wee bit carried away. The cool thing also, a good thing here is all these timber members are 50. So what I'm gonna do is I'll go back to my old view again, view, 3D views and southwest, okay? And I can fairly quickly, I can extrude these and I can do them all at once. So I'm gonna grab all of these rather than individually. I'm not going to grab the purlins, just the actual trust members and these extra bits. Oh, that's gonna be hard, I haven't drawn that one, you might. I could also mirror one side, which I thought about doing, but I'm not going to do that today. Enter, look, the trust is coming alive, I'm gonna go 50 on that. And you can see already the trust is starting to take shape. Now, by memory, we need to, is it, which one's, forward on my 3D sketch? Is it, I think these two go the other way, do they?
So the ones going in towards the ridge, the ones pointing in towards the ridge, those are the ones in front.
These ones?
No, the ones pointing in towards the ridge.
Okay.
Yep, so that one and the one sort of parallel to it.
So we can grab
Yep, and then on the other side as well.
these ones, enter, and move them up 50, right? And then we can move these ones,
Yeah, that's why I said the ones going in towards the ridge. That's on the other side.
these ones here can all go
And those ones, that's the 40.
down 50.
It's all in the same direction.
So you can see what I've done there. I initially made them all 50, but then I've moved some down and some up. The purlins and the channels. I think we'll get to them in a second. The purlins are all the same size, aren't they? They're all 6.8, is that right?
Oh no, there's some are 250 by
Some
75.
are 75,
Oh, yeah, sorry, I've already pre-drawn those at whatever size they're supposed to be, see? But I'm just wondering what length they are.
link,
So it's
68.
6'8"?
2860 or 2960 plus the 8 meters. So it's almost 11 meters.
The purlins?
Well, for, no,
And then the
Purlins
purlin
are 6.8.
68.
Purlins are 6.8, okay. So let's do the purlins, because I'm gonna stand all this up in a minute.
it actually
From end to end. It extends beyond the frame of it, yeah.
So I'm gonna click on all these.
But it does extend past that. I think it looks like it goes lines up with the external face of your columns. It protrudes past.
Okay, so I need to say, for the benefit of the tape, please check the dimensions. Enter. I didn't press extrude. Damn it, extrude.
Roger, according to your drawing, the two purlins closest to the eave, that runs alongside the eave, they actually extend sort of beyond the frame, but the ones closer to the ridge are flush with the frame. So the end ones are a bit longer, it looks like.
I'm okay if you just make them 6'8".
Okay, cool.
Is it? No, but.
Yeah, I think the 3D is more
Okay.
something that you.
But that, yeah, the 6'8" is from the edge of the concrete to edge of concrete, so it's gonna, if your truss is mounted in the middle of your column, the purlin is gonna stick out beyond the truss,
Oh, yeah.
because it's gonna be the same width of the
That's
external
okay.
footprint.
I see what you mean, it will stick out a bit, but that's okay.
So do we just say the purlin
In
goes flush
terms
with
of
the truss?
your mark for your 3D, if you make them 6'8", that's fine. If you wanna chop them off, that's fine too, so take off 50 mil each end. But I'm gonna make them 6'8", yeah,
Yeah, well, if you.
which I've just done, and some of them have, been very nice, and others have been naughty, so let's have a look and see if we can have another go at the naughty one. Sorry, it seems to be taking a wee bit longer, but at least you're getting a better idea of what to do, and you're seeing me as human. Also, these start, we'll just see what happens in the end. We'll extrude that as well. This one isn't working, so this might be a classic example of riding on the aeroplane. Go to explode, go there. Oh no. I know what I'm gonna do. I'm gonna cheat.
Copy the page.
No, I'm gonna mirror the other one on the other side in a minute. But I'm not gonna do it just yet.
That one's the other one. Next one on.
Oh yeah, I'll grab that one
That one.
and mirror it from the midpoint of here
Toast, yeah.
over to there. Okay, so I've done something wrong with drawing that one of a P line. I think I'd done a block rather than a P line. Anyway, it's back where it is. Now, the secret here is gonna be flipping this up. Also, I probably should make that some sort of timber layer so I can tell the difference. And I still haven't done my little U plates, little angles. We'll get around to that. Number 2.
Shouldn't you agree with the speed of 150?
Should know what?
Extrude it by 150 and then move to instead?
Which one's that?
The
This,
plates, the small ones?
yeah, well, the plates, I'll play with them, in a minute, you're right. Also wondering whether that would go up as well. I think this one here should probably go forward. I'm not sure how I've shown it, but I think that one's probably gonna go up 50 to there. Alright. I've got a few oddball lines here, and you probably will have a few yourself as well. And I have missed out the piece which ties all this together. So I'll leave that in your capable hands, and I'll just change these purlins to something that is a different colour, because it's kind of annoying me. Number 2, yeah, okay. Alright, so let's move this a bit closer to where we want to put it. Grabbing it all over here. And a simple 3D rotate will do that to the right place. Once again, click on the red one to turn it orange, and with ortho on, hopefully I can do this by clicking there. Yep, done. So now it's a case of moving that onto the edge, from that point there to the edge of here. But, of course, we're now gonna have to slide it, so that's where we have to do the maths. How much does that stick out? What is how much does that go past the edge of there? Does anybody have a dimension there?
1475.
1475. Let's hope that I can do this by going move, enter, P for previous. Yep. Enter
1470, sorry.
1470, enter. Here we are. Now, there's a few things to fix up here. So we have a channel here, which we've already pre-drawn. It was already there on my drawing. So I can extrude that. Hopefully this will work. This could end up being an issue. Extrude that, and I think it's is it 100?
I think it's 150.
150.
Is it 150? Okay.
Actually, 152.
It's 152 times 108 times 10L times 200. So it's 152.
150 up by 108 that way by 200, is it?
Yeah.
Yeah.
Wow. That's over design. Don't know who came up with this design. Is that weird? There it is there. So we now have to centre that, so I guess we got, I'm not quite sure what to do there because,
Yeah,
you don't want
it's
too
not-
much of it sticking out.
Yeah, it's not
But
nice.
it would still work like that. You could still put two fixings there and two there.
Yeah.
Shoot.
It's a lot of fun to do.
I think we're gonna have to
You-
leave it like that,
I
okay?
think your truss is mounted on the end.
So I will still give you full marks if you,
Smaller.
put it like that. You see the dilemma? If I move it so it's centered by say 100,
So you got other things on this side.
it's sticking out past the purlin, which isn't good. It's not good at all. So I think we need to, at least it's a fixing, we need to put it like that. Now, what I will do now is I'll copy that from, I'll use that as a common point so that I can grab that point there. And then I will mirror that. Oh no, there's one more up top. You can see him. From there to
Yeah, the top one.
up here.
Yeah, yeah.
Cool.
And then, of course, I'm going to now mirror
You're gonna have 125.
that, and that from the midpoint on here. Not gonna let me do a midpoint. No, it's not letting me do a midpoint. Okay, I'm gonna have to do the same again. Don't worry,
How about if you rotate it that way?
if I rotate it
Yeah,
that way.
yeah, and use the midpoint.
So go view, 3D views, front. Like that. And then just go, mirror. And grab that. That. And that. From there down to there. That's what you meant, right?
Yeah.
And voila, well done. No, not half a mark.
It's not fair.
It's up there, yeah. You can, yeah. Okay, so actually, I was gonna explain that to you. That is, you can always revert back to your front sideways views, but we still have to, put all the trusses along. So the best way to do that is to go view, 3D views, and go right. And you'll see the purlins are there, but we now need to copy our truss along. So we can do the maths to how far each truss is. We can also mirror that first one, which isn't a bad idea, so that it's on the other side. So, see that, by doing that view, I was able to mirror the whole truss with a blue window, right? So view, 3D views, right. I don't know how many trusses there are or what the actual distance works out at. So,
put 9
Yeah.
total.
yeah, so there's 9 in total, so you need to, with ortho on, type in the number and then it'll dump it in the right place.
Do you use the divide tool?
No, I've only done a few here, haven't I? Only done 1, 2, 3, 4, 5, 6, 7, 8. I would be reluctant to use the divide tool, a bit like I was reluctant to do what he said, but you could try that, yeah.
Offset this.
Or use your calculator and just copy it. It's not really that critical because it's a 3D. 3D drawings are used in AutoCAD to sort of show the client what you're going to do. And so the level of accuracy is a lot less than likes of Revit, where you have to get it dead right because it's giving you quantities, which gives you prices. And you know, if you don't do it dead right on Revit, then the roof won't go on or a window frame won't work or something. We use 3D and structural and CAD to kind of just give the client an idea of what they're going to get. Okay, so that's why I was before when you were saying, you know, that goes here or is that overhang there. Yes, it's sort of critical, but it's not as important in mine. So, look, I've only shown 1, 2, 3, 4, 5, 6, 7. There is 9. You need to work that out. I'm sure you'll when you go back through the tape, you'll do it. But the cool thing is you're getting a good idea of what it looks like sideways, and you can already see that you know what it's going to look like. There's going to be that piece of timber sticking up. There's going to be the plates. There's going to be the purlins, and there'll be the 2 bits of timber at the top. So when you turn that round like that, you can see exactly what your 3D, what you should be drawing in 2D. All right. So that's what I mean by giving you quite a good hand. I'd do the 3D first. You know, while it's fresh on your mind, whip it up this weekend. There is no wrong here. You know, you just go back to the tape and make it, have another go. You were wondering about the holes. What are we up to? 11, 19. I could do that for you. Why not? So you do a circle. It's a 16mm bolt. Say for example, I'm going to do that at 8, and I'm going to extrude it by 100. I'll rotate it. Read one. Up. Oh, didn't rotate. Read one. Up. Pulls it down. Oh, we have a bit of a problem here, Houston. It's not rotating.
Also, if you can take it, you can rotate it anywhere along it.
Did I take? No, the ortho is on.
Your wrong axis. Yeah.
You have the wrong axis on the 3D.
Did I? Okay, we'll try that again.
Use the yellow, green one.
Oh, you're right. Now I'm going to move that onto here. This is pretty cool. This I quite like this part. So when I say it's cool, that means it's cool because I've been doing it for 20 years. And now it's not working. I'm going to move that from the center of the circle to there. Okay, I'm gonna move it across a bit, and I'll locate it somewhere there. I'll move it down, so I'm moving it down into the concrete. And now I'm gonna go back here to the subtract, and it says select the object you want to keep, and then press enter, then select the object you want to subtract. The object I want to keep is that one and that one, enter. The object I want to subtract is that one, enter. Then we have a hole there, and for some reason the plate turned combined with the concrete slab, so that wasn't quite the result I was after. So I'll do that again, subtract, select the red one, enter, select that, enter, and now we have a hole through the plate. Whoops. What the hell? Yeah, it's the sort of thing that happens in 3D, you suddenly lose control. So there's your hole, like I was talking about before. You put holes in your plates, that's kind of heading towards half a mark. Now I'm going to draw a rectangle. Now, the proper way to draw a rectangle is to do multiple circles and join the intersections. In other words,
Sorry, I will put the holes on the plate or bolts on the plate.
yeah, but what you can do is you can do multiple circles and where the circles intersect, you then join them up to make a hexagon, okay, or whatever it is. That's how you can draw a hexagon. Or you can divide the circle into 6 using the divide command. I won't do that, I'm just going to sketch it because I'm lazy, and then we'll see what happens from here. So if I do a P line, I'll just do a circle that's, for example, I don't know, 12, and then I'll do a hexagon shape from here to here to here to here to here to here to here, and then I'll extrude that, and we've got our nut. See that? One nut. So you can put your cylinder on there. So I'll do a circle from the center of here, about that size. I'll extrude that, and we now have a bolt. I'm going to make that a bit bigger and extrude that. We now have a washer and a bolt. I can copy the bolt to the other end. This is an example of drawing a bolt yourself. We now have a washer and a bolt ready to go into my drawing. Now that would be about 0.1 of a meg, maybe even a lot less, 0.01 of a meg. You bring it in from the internet with all the threads on it, and you'll blow your drawing size pretty quickly.
Threads being the little things that go around the.
Yes, yeah. And the nuts do too. It's all been, they're basically done one of those things called where they model it on a 3D printer type thing. Yeah. So they've 3D printed it, then they've turned it into a 3D object for AutoCAD. which is fine if you were doing that sort of finer mechanical drawing type work. So yeah, that's an example of a way of doing the washer and a nut, and you know, it doesn't look too bad, and you get full marks. I mean, I just roughly drew that. You can see the hexagon's not very, not the best. You could do it properly with circles and things. Divide the circle into 6, and it'll put 6 nodes around it, and then you can join them up. Alright, so you've got enough there that I drew. If you copy what I've done, that's going to get you 60%. And for some of you, that might be all you need to do. But there is one last thing to get this right. And if I bring it into the viewport, you go, what the hell?
That's like plan view.
It's like a plan view and it's not rendered. Right? So let's go back to the model, wherever I had it. Okay, so using Ingrid's technique of shift key down, middle roller, you know, I've got the model looking pretty cool about where Roger had it. I've zoomed in on it. It's all rendered. What's wrong? I've gone into the viewport and it's in plan view and it's single line. So what you have to do is go into the viewport, go view, 3D views, oops, view, 3D views, isometric, so that gets it back looking a bit more like that. And then you've got to go, while you're in the viewport, view, visual styles, and then of course change it to sketchy. Oh, I said I'd do that, didn't I? Okay, and Lance missed that. See, shouldn't be nipping out during class. View, visual styles, realistic, bang. And that's fine, you can leave it like that, and that gets you 60%. Now, the things just to bump up that from 60 to 100. The pipe, so I've shown you a cylinder, so that shouldn't be too hard to do. The trench going around with the pipe in it, with some sort of filter material. The hard fill underneath, that should be fairly easy to do as well. Nuts, bolts, and of course Dynabolts. Now a Dynabolt from the top looks a little bit like this. So it looks a little bit like a nut with a washer on it. And that's all you're going to see on the plate.
Plan view.
I don't need, I don't have enough time to go in everyone's drawing and pull their bolts out.
Sure.
Because in sideways view, a Dynabolt looks a little bit like this. It's got kind of things that, like 2 arms. And when you tighten up the bolt on the top, the nut, it pushes those arms out that way and that way into the concrete, which holds it all in, you see. And so you don't need, I don't need to see that on 3D. I'm just giving you an idea of what it looks like. And when you're doing your plate detail, you're looking down on it, so I don't need to see all that either. Okay? There's many ways to put plates on concrete. Probably the best way is to set, they have a thing that is, whoops, that you buy these brackets and it's a plate that fits into the concrete, here's your concrete, and it's got bolts coming up with the threads on them. And you obviously put the plate over the top and do the nuts up. Now that's good, except I don't know if you've ever seen concrete being poured, but it's pretty rough. They're all big rough guys doing it, all yelling out stuff to each other, and the concrete's going everywhere. This will have to be set to the nearest mill to get it right for all your other calculations, and level. You can't have the nuts on an angle. So you do need really good concrete layers to get that. Whereas this way, you just drill into the concrete afterwards and put your Dynabolt in. It's a lot easier, yeah. And you drill through the holes in the plate, so you don't get it wrong, yeah. whereas that opens up to, that's the best way. That's never gonna fall down in an earthquake, but that one might, but that one won't. But you need top guys on the job, yeah. So if ever you're supervising that, make sure you're around and doing all the measurements on it to get them dead right. Okay, I've shown you that. The only thing I need to do before we go on is I need to just quickly go through the timber notes. There are a couple of things that'll be in the test I need to show you, and also some notes you can put on your drawings. So the timber is I'm going to make available now.
Roger, this test is next week, eh?
I think so. It's on your timetable. It's only 10%, but it's worthwhile putting an effort in.
Just one thing, Roger, I saw on the material quantity table, that's a thing called concrete pad, where the concrete pad should be. Concrete pad,
Sorry?
concrete pads on the material quantity table.
That's only an example. If there's no path, don't put it.
Oh, okay, yeah.
It's just to show you what it looks like. There's a couple of things like that. So if you can't see it on this assignment, don't worry about it.
Okay.
Sorry for the confusion. For some reason, the timber notes can't be seen, and I'm not sure why, by the common people. Make available but don't show on this page. Make available, hide, I don't have hide
Are
on
you
this.
in teacher view or?
Are you in student view?
Make available but don't show on this page. Show subfolder, show, include in the course. I can't put hide on the course page, it has to be make available. Restricted access, none. Tags, none. Competencies, none. Display folders in line with the course. Display description on course. There's no dates there. I can't save and display. Sorry, can you see anything in week 6?
Wait. Week 6 or 10?
Are we 11?
11? No, I don't see anything.
Okay, I'm gonna make another one. Add. Is that? Oh, I've hidden this. That's better. Okay, can you see the timber notes now?
Yep.
All right. Now, have quite a few of you already done a subject called materials? Excuse me, I'm just wanting to find out if you've done a subject called materials
Yeah,
already.
I'm busy with it now.
Most of you got the big B or C or A or whatever for that. You passed it. Okay.
Yeah, whatever.
You haven't passed it? Okay.
Work in progress.
All right. This isn't really about how we make timber, how we cut it off the trees and we take it through the different processes and all that side of it, which is what materials is about, like concrete, how to make concrete, what goes into it, etc. This is about what we put on our drawings. So you'll find that there'll be bits pinched from the materials notes, but only the bits that I want you to put on the drawings, okay? So, in a kind of a nutshell, the most important thing about timber is that you tell me the following things. I would like to know the grade of the timber, the type of timber, and the nominal size of the timber. And when you're doing it on the quantities table, I'd like to know the length as well. So although my notes just say timber truss, right, you need to also call these things up. And you'll notice that in my example, there's a section there that says the grade, the type, the nominal size, and the length. It's also important in the elevations to call them up as well. Now you can do this by a comment, you can do this by using this. So you could put an arrow to one of them and put TYP. Does anyone know what that means? It's short for a tip for the teacher. No, it's not. It's TYP means typical. So if you point to one, it's typical for them all. You've covered that with one note. And you can do that with reinforcing too. And you can do that with also with other things in engineering. You can put the full word typical, but that generally is what we do in drawing. Another way of doing it is to refer to the notes, and in your notes section say that all the timber is radiator pine of grade such and such, blah blah blah, and so you've covered it in the notes section, but you refer to it, right? So you've got a few choices. I personally, because when I was doing drafting and drawing, my engineers used to give me notes for the notes column, and I used to type them up and keep them on my own hard drive. So every time we did a drawing, I went cut, paste, and then I'd take the ones out that weren't important. So I covered everything in the notes, and it was a simple cut and paste, so easy drawing. But I always referred to the notes from the main drawing, just like you did with your civil drawings, all right? I'm always looking for that. You wanted to make me happy, you do a reference to your notes. I'm going to cover the grade in a minute, the type in a minute, the nominal size and the length. Nominal size is important. It's the call-up size. But it does vary, and I'll show you that as well. And it's more important to a registered engineer, the actual size of the timber, because they do the beam to the actual size. And what happens with timber is that you would have seen movies and that where it goes through the mill. They put the big log through and it cuts the timber the first time into the sizes that you want. That's called rough sawn. Massive big saw, they put it through. Then they pass it through like a gauging machine, and that takes a bit more off the timber on the sides. And then if you want, you know, like architects and people with flash houses, they've got those beautifully finished timbers that they stain or they paint all nicely. That's called that's the perfect finish at the end. I'll cover that, but that takes another 5 mil off. And of course, when you're a structural engineer, you're doing calculations for the area of the beam, and if you keep losing 5 mil all the time, you're getting your calculations wrong. So you should always do the calculation on the actual size, but the call up on the drawing is the nominal size. So there is a difference, and to a structural engineer it can mean quite a bit. So when architects put a smooth finish on their drawings, the structural engineers, it starts driving them crazy because they have to redo their calculations again to make sure buildings are going to hold up. If you had a beam from there across to the other size there, 10 mil off the whole beam can make a big difference to whether it's going to hold up or break, right? So the nominal size is important. Obviously the length is important, that's what you're going to work out. Now when we have a member that comes down like that and goes up like that. You don't measure it from there or there and average it. Your length will be as if it's cut out of a piece of timber like that. And then I would add on always 100 millimeters. Because you want to, you'll order the piece of timber and then chop it down to the exact size for your truss. You don't want to be doing the exact size and somebody in a timber mill, some dude comes along and goes, oh, yeah, that's about right. Yeah,
So if there's multiple
pieces of timber.
pieces, yeah, out of the whole thing, do you keep adding on top of that?
As a general rule, believe it or not, they actually use a 10% factor for cutting, because you can't always get the timber the lengths you want. So say it came to 6.3 and you can only get 6 metre bits, then you're obviously going to have to buy another 6 metre bit. Yeah, and cut that off. Now some timber yards will say, oh, you can take a wee bit off that, mate, but others will say, no, you've got to buy the whole shebang.
And then
So
6.3 meters plus 12 meters of supply.
yes, yeah. So 6.3 equals 12 metres supply. So in that case, you've lost about 40%. You're paying 40% more. But you're always better to be a bit over anyway. Nobody's going to criticise you if you take a bit more. Most timber yards will take whole pieces back. So you can, take it back to them and get a refund or on your docket. But in this case, in my drawings, calculate that, add 10 mil. So I'll give you leeway. If you don't add 10 mil, I'll still mark you right.
10 or 100?
100, sorry. See, well, 10 centimetres is what I meant to say. Yeah. Sounds
So
quick.
you deal with meters or millimeters.
Yeah, sorry, no. That's another point of contention. Kiwis is millimetres or metres, but countries like India, China, Middle East, Europe, they're all centimetres, and that makes life hard if they come here. And then if you're from Britain or US, well, you've had it, because that's all feet and inches.
Well, if you, technically, it's only the countries that use the aerial system that have actually put somebody on the moon.
Oh,
Yeah, so the metric system isn't all that good.
well, there we are. So maybe, yeah, that's right. Yeah, but then if you compare Russia with America, the Americans spent, what, $1 million trying to make a pen that worked in space,
Use a pencil.
and the Russians use a pencil.
But should we just have a recap on the text height if you finish with that one?
Text height is 3.5 millimeters for most of your text, and arrows as well.
That's in the layout space then,
And layer, yeah. And the calculation is really difficult. 1 to 20 is 70 millimeters in model. I'm being smart when I said it's really difficult. It's a millimeter drawing, so you don't have to divide it by 1,000. Yeah, so everything's in millimeters now. All right. Generally, as a rule, architects only use millimeters, and so therefore when you start doing site drawings, they get very confused in AutoCAD of what's going on, because they generally don't use meters. And mechanical engineers do millimeters, they don't generally use meters either. So it's usually civil engineers and surveyors are the only ones that have to worry about that extra calculation. Yeah, it's handy to know. And the other thing is that a lot of companies don't draw in model space, they do their text in layout space. And you can link dimensions to a viewport. It gets pretty confusing, but you can do it, and that's quite a good way of getting around the whole calculation thing. Okay, so if you do it exactly, I'll mark you right. If you're within 100 mil, I'll mark you right. So you got me on your side there. Okay, and like, sorry, I don't know your name. What's your name, that lady there?
Me?
Yeah,
Yenny.
Yanni.
Yes.
Like Yanni says, you could add all them up. In which case, I was going to say just add 100 mil to the total, but the problem with that is that when you add them all up, you might just go over what the timber suppliers have got. So if you are going to add them up, probably best to add 100 each time. All right.
Do you put any text on the 3D?
No, you don't need to do that at all. I know in Revit you can do that, and Revit's pretty cool in that it pumps out 2D drawings from your model. So you hit a button and it pumps out a 3D. You do your model and it pumps out your elevation drawings with text on it and dimensions. So that's another good thing about Revit. Although they're not necessarily to a proper standard, but companies these days now are pretty smart. They've developed standards for their 2D drawings.
Do you think
Yeah.
it will be more easier because of AI?
More easier what?
Do you think it will be more easier AutoCAD in upcoming future because of AI?
I see AutoCAD as being used differently. I think you're going to be using it for things like aerial. See, AutoCAD's very close to Civil 3D. It's really close in terms of the two programs. But Civil 3 doesn't do the whole. Oh, yes, it does. It also does here. So AutoCAD will be used for bringing in aerial photographs, for doing drawings with pictures in them, for GIS works really well with bringing in GIS information from councils and governments. And it sort of also works really well with other things like mechanical, architectural, electrical. So I think it'll be used differently. I think the world will go for the modelling side of things with structural eventually. The only thing is that you don't really want someone coming straight out of school and using these programs, because that's why you're doing your degree. It's kind of saying, oh, you don't need to do a degree, it's a waste of time. Let's take a school kid and start using models. You know, and they're there playing on them like it's a PlayStation game, and they don't realise that they've just put a plate somewhere and they should have done the design before they did it, or, oh, that beam looks nice, let's use that beam. But they don't kind of grasp the concept that you actually have to do some calcs to work out what beams should go where. So you've got to sort of be careful you don't have the tail wagging the dog. I think the dog needs to be someone that's that's done their qualifications, and then they move on to the modelling side of it. So you've got the right people driving them. Yeah. About 10 years ago, they stopped putting students through the likes of Unitec, and the companies were pinching them straight from school. So you'll see a lot of students around the 30 to 40, probably closer to 40 mark, who have from school gone straight to consultancies, and now they're making them come back to study again, and it's hard. It's really hard for them because they know what to do, but they've got to learn all the theory again. Yeah. So the other thing is the companies have put years and years of training into them when they could have got it for free by sending them to Unitec. Yeah. So the answer to your question, CAD, I think will go more the civil way. There is the fact that Revit costs more money, and it is also Revit takes a bit of training to get to a high level at it. So you can't really give our first year students Revit until they know a bit about what they're drawing. So that's another complication. The architects use ArchiCAD, which is a kind of a program that Mitre 10 might use, you know, kitchens and that. And they make them do simple little drawings and then they put them on Revit. I think it's important that our guys do the CAD because they can do civil and structural drawings while they're learning and then put them on the modelling programs. Okay, we haven't got a lot of time left because I've talked too much. So the grade is the most important thing, but we'll start with the treatments, and the main treatments that we do is what's called tannalization, which protects the timber against water and rot from the outside elements, mostly rain and water getting in to the building. So tannalization comes with a factor, and at the end of these notes you'll see that I've got a table, and on that table is what I call the tannalization factor, and it's usually with an H in front of it. Now the higher the H, the more resistant to water they are, so you can use them for piles in the ground and also in water situations for piers and things. It does go past H5, I believe, a student once told me, but my notes only go to H5. And then you get down to H1.2, which is your timber framing, and you're hoping that that framing is only exposed to weather for a short period of time. So it is weatherproof for 3, 4, 6 weeks, and then you're hoping they'll close the building in at that point, okay? At one stage in New Zealand, they dropped right back to non-tannalised timber for framing, and we got the leaky home syndrome. I want you to give the timber an H factor for the assignment. I'm suggesting 1.2, 1.3. I also want you to decide back here in the notes. Oh, sorry, there's your split rings and the timber joints I was talking about. You'll see the split rings, how to detail them down here, and you'll see the joint. See how the claws go into it? It's pretty cool. So they hold the timber together with a bolt right through the middle of it. There's the split ring there, 2 bits of timber. Looks like a giant
it's
clamp.
like this one or like this?
This one here, there, yeah. So timber and timber, and a bolt between, tightening it up. Like I said, like one of those things they used to in the medieval times. Okay, so the dress timber is drawn like that. A block is only a small piece of timber holding 2 pieces apart. You don't have any blocks. And a continuous member is this one. So when you cut through it, you're showing a cut through view. You do a crisscross on your detail. All right. The other thing that you need to worry about up here is, so I've talked about the species. You are going to be using radiate to pine. And I'm suggesting that most of your timber is going to be rough sawed because it's only a garden shed. It's not a house or a lecture theatre or anything like that. So a bit of feathering up there is probably going to make no difference at all. It's probably not going to be finished to a great finish at all.
What would that save in cost with rough sawn as opposed to?
Yes, yeah, and you're saving costs with rough sawn, yeah. And you can put that in your presentation if you're talking about the materials. I did need to show you this here. So this is what I was talking about. If you get this is, the rough sawn is the call up, it's the nominal size, and it's what we call it up. This is what architects start asking for in flasher buildings and flasher things, because it paints up really nicely. That's probably what your deck handrails would be gauged. So it's pretty smooth and easy to paint, and that's your really super flash stuff. But look how the size is getting smaller and smaller for your engineering calculations.
You're taking off material.
Yeah,
As you're finishing.
and as you know, when you're looking at cantilevers or looking at beams, it's the cross-sectional area is the important bit.
Anyway, that's when your
Yeah.
brothers
Yeah.
You
So
take
that-
material off.
That's kind of the very first step in an architect getting a punch in the nose from an engineer, because they forget to tell you that they want dressed timber,
Right, it's 10 mils
and
less,
you have
so
to go back and do a whole bunch of more calculations.
when you're around at the end of the wall and you're 3 slats short.
Yeah, yeah. You can tell an architect a mile away. They wear a shirt like I'm wearing today when they're on site. Yeah, engineers are generally dressed in black.
And how is it that the hierarchy of an architect is higher than the engineers?
Well, often they win the job because they talk the talk and they woo the client. And they did it to me with my house build. You know, 3D model, walking up the stairs, lovely view. You know, the minute you get there, you got the high windows and look at that. Yep, I'll have that, thanks very much. How much money do you want? You know, the engineers never do that. Oh, we've got this.
It's always a problem with
We've got this
engineers.
big long beam. You won't believe how wonderful it's going to look. Yeah, it's not the same. Sorry to disappoint, but you're probably never going to be a rock star in engineering. Okay, so there are a number of things here that I would revise for the test. The splice is a question in the test. It's for lengthening, not strengthening. The lintel is a question. There's a question on the stiffener and the portal frame. There's also a question on moisture content and fibre saturation point. Now, moisture content is important in timber before you can put any coverings on it internally. You must get the moisture content down to around about 14–15%. The fibre saturation point is something that you'll find when you go to a timber yard and it's been sitting out in the rain for weeks and it's got so much moisture you can't take any more. It's reached its saturation point. Man, is it heavy. It is really heavy. You take a 6 metre long 6x2, you know, if it's dry, you can just about pick it up yourself with one arm. You know, some of us can. But if it's wet, you got no show. Really, really heavy. Even with 2 people, one on either end. So
Yeah, you get the excess, the free excess.
they try not to build in anything that's reached fibre saturation point, but sometimes it's a little bit difficult not to actually build without it. If you've got timber waiting and you've got guys on site, they generally will be picking it up anyway. So the split rings is quite cool because you've got a couple of details here, the sideways one and a plan view of that's the side, that's the plan view, that's the sideways one of what the split ring will look like. I do talk about other things in the timber notes, but they're not relative to the test or the assignment. We also talk a little bit about bolts, and any bolts in timber is called up that way with a distance and how many bolts there are. We don't actually do the individual little dimensions on timber. There's what I was talking about with the detail. You have the hole and a centre line showing that there's a bolt. And nails, here's the different types of bolts available, I think you're probably going to be using engineering bolts, and you have got some coach screws. That's what they look like there. Okay, that's the ones that go through the angle into the purlin, and you are detailing that, so it's a good idea to.
Coach screws going for concrete?
I'm pretty sure they go through the angle into the. No, the concrete's a Dynabolt.
Little coach screws that go into concrete as well.
Oh, you can do, yeah, you can, yeah. I gave the diplomas a question. If any of them, here's another chance for a half a mark, not for Lance. So if Lance could answer, it'd be quite good.
You tired of giving out more?
So apart from William the Great in 1688, that is a nail which looks like this, but it's got two heads. I'm not being gruesome, it's not a horror movie. Anyone can answer this question. What would you use it for?
Well, you use it when you want to remove it later on, right? So you put it in, and then.
He's been talking to the diplomas, hasn't he?
No, I haven't. Honestly. You put it into something where you plan on taking out later. Say you're putting, I don't know, some meters on a slab, and you fill the slab. If you put it in, then you can easily take it back out to remove the boxing later on. Something like that.
The real answer is when Sir Lancelot put it into the stone and he pulled it out.
Oh yeah.
You're right, you're 100% right.
Okay.
So they put those into the nail gun,
Yeah.
and when the nail gun shoots it in, it stops there, right? So if you're bringing your Harley Davidson from India to New Zealand and you pack it up in a big box thing, and you don't want anyone to damage it, when it gets here, you just quickly can open the box. So they use it a lot in packaging, but in engineering we use it a lot for, remember that sketch I did of the concrete with the false work? Yeah, so if they use these nails with the nail guns, the lackey's kind of like an apprentice, or the person, the labourer, they'll come along and very easily remove it already ready to pull off the shuttering for a big retaining wall or something and move it on to the next job.
So that was correct? Sorry?
Yes, it's correct. Yeah, yeah. Yeah. So you two can have a little private Friday night celebration of half a mark.
Do we also need to do the welding of the car?
Do we also need to do the welding? The welding is, yes, you need to call that up. So the welding from last week was an arrow like that and a 6. You need to decide whether there's a circle there or not. You need to decide whether there's a circle and an arrow and a flag, like a golf flag. You need to decide, is it a triangle like that, a triangle like that, or 2 triangles? So 1, 2, 3, 4, or 2 triangles, 5. It's a fillet weld, and it's obviously welding the H or the column onto the plate.
So I have to do the details of the thing.
Your detail will be looking down on it.
Yeah. I have
So
to be it.
it's going to be like that. The H is like that.
Yeah.
Where you put your holes might be like this. I don't know. It's going to have like a schoolboy's beard. Mine used to be really, really, really fluffy. It's gone all a bit like this now. And you need dimensions to the holes.
Yeah.
I don't know. You might have a hole over here, over here. You need to call up the holes, and you need to call up the bolts. And that's what it's going to look like. I can't do it all neat and tidy, so I'm pretty much just giving you something to copy for marks. But I'm just saying. So these holes are based on your plate design, and your hole plate design. So you have your minimum and your maximum. So you can't breach the minimum and you can't breach the maximum between. But
That
you
was
can.
in 3602 standards, eh? Would it be under concrete or? would it
It's
be
in the
under
notes.
steel?
It's in the notes, and I also talked about it on the video. Yeah. You ignore the H in terms of the fact that it's not a distance to the H, it's a distance to the edge of the plate. But you've got to keep a little bit away from the weld, because the weld is in here like this, and there's your hole.
You don't want the weld getting in the way of your nuts, bolted.
Yeah, and you've got your bolt on top like that, and you need enough room to put a socket on top and screw it down. You can't have it hard against the weld.
And does,
Yeah.
sorry, we get to we're told what the size of the base plate is.
No, you've got to make that up yourself. There's a couple of dimensions there which you'll have to abide by.
Yeah, but I'm just worried about the minimum requirements and the H beams they're gonna clash
The minimum requirements for,
for the bolt placements and the H beams. They're gonna clash in that sort of format. Can we?
yeah, so if you extend the base plate a bit this way,
And that way.
then you might be able to get another.
That's what I'm thinking, just in
Yes.
case our minimal don't fit in
Yes.
with the alignment we got out there.
Yeah, so you gotta actually, in the past, the elevations and details were a secret assignment, and I used to be rather mean about it, because I would say to the students, you do the first assignment, and then they'd all come back and say, can we change our plate please, we did it wrong. And I'd say, no, I gave you good marks for that, but you can't change it, so you lose marks in assignment 2. But this is the whole assignment, so you have to take into account that exactly what you said. You may need to increase, now don't increase it too much, because then you're gonna have too far between the bolts or too far to the edge.
Tractor driving over there now.
Yeah, so you breach your minimum or your maximum actually, yeah. And of course you have to put your plate into the steel quantities, so I'm hoping everyone has slightly different length there. That's why I said jokingly, make it 399 or 423 or something, which will make your quantities different as well from the Hey Bro. Yeah.
How many questions do we have for the test?
3 from concrete, 3 from this one, and 3 from steel. Actually, you've just helped the whole class then, well done. See these 2 diagrams here? I can guarantee you 3 questions out of those 2 diagrams. I've told Moodle to make this class get 3 questions out of those 2. And the interesting thing here is that the dwangs are the same as where it says wall knob or dwang. So they're actually, they can be that one along there or that one along the back.
And you won't accept whalers, eh?
Not for this one, no.
Sorry, Roger, dwangs are your horizontal and the studs are the vertical ones, right?
In between the studs, yeah.
Oh, yes, okay.
Yeah. So the dwang is something quite interesting, because the dwang is a South Island thing, mostly where I come from, down the bottom. We all call them dwangs.
I searched it up online, it says like an error in the spelling.
So it's not an error, it's,
Slang.
see, this is just like people in China making fun of people that come from the capital, because they all speak like that, right? We speak down in the South Island, and they're making fun of me, because when they can't actually say the word dwang properly, they go gwang like that.
Totally.
So it's a South Island thing, Gurang, and North Islanders call them Nogs, alright? But I wanted to put it on there because I can. One day when I'm not teaching here, they'll take that out, probably.
Just add on the tongue. It's annoying.
Yes. Yes. So do you talk with Ara like that?
No, I can. I used to study in Beijing for a couple of years, but I learned how to, but it's still annoying. They actually like shorter a few words like shorter. 西红柿工人 It's annoying.
So that when the New Zealanders first came here, the British, they all went out and bought land in the farms. And they used to only see each other about once a month. They'd see each other on the farm. But farmers didn't like talking very much, so they just use, you know, instead of saying, I'm going to sit on my tractor, they just say, sit, tractor, bite, and off, right? So the English, the proper English got shorter and shorter for the people living in the country. The people in the city still spoke proper
Native
English.
speakers.
So, yeah. Yep,
9 questions for the class.
9 questions
So 3, 3, 2.
and 11, 2 or 3 from these two. There and here. So before the test, if you have a good look at those and learn them, then you're bound to get 3 questions on these. And the reason why I've done that is I think it's very important to know the building terms. Even although you're not architectural draftsmen, it's important when you go on site to know what things are called, because as engineers you might be called on site to say, we want you to check a beam that is hanging off the top plate, you know, and you say, well, what's the top plate? It's nice that you know what it is, so you know where to locate it. The other thing is, they might say to you, the house is going over the boundary. Can we bring that beam back a little bit or do something like that? And you say, what do you mean over the boundary? Oh, the fascia is over the boundary. What's the fascia? It's there on the corner, this one here. So 2 or 3 from there, and about 9 or 8 calculations. The calculations are going to be a reinforcing drawing, which I will go over some maths on. I'll go back over the one that we did in class. I think it's one in class that I'm going over. It might be a bridge abutment. Anyway, I'll go over it.
You have the test next week.
Yep.
Can you do it before the test?
Yep. Then I'll give you half an hour to have a look at the mathematical side of it. Nothing that you wouldn't have had to do for the assignment in terms of the calculations. There'll be a plate design one as well. So we'll sit there and we'll go over a few plate designs in the test. So for some people it's like, oh ho hum, I did that with the assignment, I know what to do. Others are like, oh, I didn't know that's what I was supposed to do. Okay, right, you know, that's the maths, I'll do that. And the good thing is you still got time to do your assignment and correct it, because the hand-ins are after the test. So if you've stuffed it up, you can go back and do your assignment properly. Plate, the steel schedule. Remember we did a girder? Same girders in the test, but different members, different plate sizes. All right, I'll go over that.
Same what, sorry, same,
The girder that we
Yes.
did in the class exercise is going to be in the test, but it'll be different members, different beams and things.
okay.
All right? Yep.
What does DPC mean? What does it stand
Damp proof course.
I couldn't remember what the
Yeah,
C was.
course. So I'll explain it.
Course.
Um,
Course.
C-O-U-R-S.